All right, we are live for yet another Akka.net community stand-up. It's March 2023. We just shipped Akka.net 1.5 last week, which was a big project that we've been working on for probably over a year. Wouldn't you say so, Gregorius?
Mm-hmm.
Yeah. So let's go ahead, I guess, kick this thing off by talking a bit about our recent Akka.net releases here. So obviously, Akka.net 1.5 is kind of the main portion of the show here. I already went ahead and opened this. I am going to go through in today's stand-up a bit of some of the same things we kind of covered in our new features and upgrade guide. I'm not going to get into all of the different, how do I put this? I am not going to get into all the different upgrade steps for cluster sharding and some of the other stuff that made this video 30 minutes long. We're not going to cover that today. Mostly what we're going to do is kind of quickly recap what made it into Akka.net 1.5. And then we're going to talk about what's coming next on the Akka.net roadmap after this. Pretty much at this stage, I think every single plugin has now been updated to support Akka.net 1.5. So we have updates for Alpaca, Akka Streams Kafka, every Akka Persistence plugin, every logging plugin, every test kit plugin, Petabridge.command, Phobos, all that stuff has all been upgraded to Akka.net 1.5. So that should all basically be out in NuGet already. You should be able to go ahead and upgrade everything to it. Anything that's maintained by either Petabridge or the Akka.net organization should have been upgraded at this point. In fact, the only one I can think of that may not have been is Akka.Persistence Extras. So we might actually need to make an issue to go do that, Gregorius. But other than that, I think that's everything. So I'm going to jump straight into our little show and tell presentation because it kind of covers all the normal stuff we normally have in our agenda. We're going to recap Akka.net 1.5 and talk about what's new in core Akka.net. In last month's presentation, we talked about the new libraries we introduced, so Akka Hosting, Akka Management, and Akka Health Check. We're going to mostly touch on today what's actually changed in core Akka.net as a result of Akka.net 1.5. So let me spin that up, and we'll go ahead and dive right into it. Okay, and then let me get rid of this. So what has changed in Akka.net 1.5? What are we still planning on working on as part of the 1.5 development cycle? So we do have some additional features and modules planned. We're going to share those. And then what's planned for Akka.net 1.6, which will be the next minor release of Akka.net. Well, we're going to touch a bit on our Akka.Remote's new transport system. That's probably the biggest thing. We'll talk a bit about the serialization overhaul we have planned as part of supporting that. And then we'll also touch on AOT support. This is important for people who want to run Akka.net on platforms like Unity 3D and Xamarin, for instance. So what's new in Akka.net 1.5? Well, first, we have basically a bunch of new libraries. So Akka Hosting, which is kind of probably the star of the show for Akka.net 1.5. This is essentially our integration point with all of the Microsoft.Extensions libraries. So we have Microsoft.Extensions configuration support, logging support. We also have real dependency injection support, where you can actually inject Akka.net actors using a strongly typed key into non-Akka.net components. That's what the required actor construct allows us to do. And this is all powered through a little DI container that Akka Hosting itself uses, called the actor registry. It's basically a place to store actor references after they're created. All actors get stored using a unique, strongly typed key in there. It's not meant for looking up millions of actors. It's meant for looking up a small number of really important actors that tend to live over the course of the life cycle of your application. We'll be releasing a dedicated video on, it's going to be basically a recap of our February Akka.net community stand-up. But we're going to be releasing a dedicated video that goes into some more detail on Akka Hosting and Akka Health Check and Akka Management. Akka Health Check, which we're about to do a new release for today, is our liveness and readiness probe system for Akka.Persistence, Akka.Cluster, and really anything in Akka.net. It's designed to integrate with the Microsoft.Extensions.HealthChecks library and the Health Check service. And this is highly extensible. It's really easy to go and write your own probes if you want to. If you follow this integration and you use Akka Hosting, it's very easy to go and tie these Akka.net health checks in with your normal ASP.NET health checks if you want. It'll all tie into that sort of health Z endpoint you might have on your web applications. So this should make it a lot easier for people who are running in environments like Kubernetes or Azure App Services or whatever to get accurate sort of health check information about the condition of their Akka.NET cluster if they're using it in this environment. And then finally, we have Akka Management, which we covered last week. This gives us the ability to discover potential seed nodes to form a new cluster together dynamically. So we have dynamic discovery plugins for Azure, Kubernetes, AWS. And then this allows us to automatically bootstrap new clusters without needing static seed nodes. So no lighthouse, in other words. And one of the most important things that Akka Management facilitates is it makes it quite easy to run Akka.NET on, we'll go ahead and call it we'll call it lightweight platform as a service environments. So these are environments like ECS or on Azure, it might be Azure App Service, Azure Container Apps. This will help lower the total cost of ownership for running Akka.NET. And on top of that, I think Akka Management is actually much more robust from a fault tolerance standpoint than the static seed node system was. So we're going to be pushing a lot of this material into our examples and documentation going forward. That's one of the big projects we have underway following Akka.NET 1.5. In fact, I'm just realizing that did not make it into my presentation, but it should still be there. So we have a lot of work to do trying to help push these practices into the .NET user community. The next big change, now we're actually going to start talking about things that affect the core Akka.NET DLLs you all been using off of NuGet. The first big piece of this is .NET 6 dual targeting. Akka.NET has targeted .NET Standard 2.0 since we shipped Akka.NET 1.4 in 2020. So we still support that. And .NET Standard 2.0 supports, I think, everything going all the way back to .NET Framework. It's either 4.61 or 4.62. So you're still going to be able to use Akka.NET even if you're running on good old .NET Framework, or if you're running on .NET Core or .NET 5, you can still use Akka.NET 1.4 no problem. It's just that now we also target .NET 6. So if I take a look at the NuGet package, you'll see that it targets .NET Standard 2.0 and .NET 6. So it's a dual targeted assembly. If you are referencing Akka.NET 1.5 or higher in a .NET 6 or higher application, it'll automatically use this version of Akka.NET. What we are trying to accomplish by doing this is taking advantage of some newer .NET APIs for performance reasons primarily. And so I'll give you an example of one of these. One of the new .NET 6 APIs we took advantage of, although really this was introduced in .NET Core 3.0, is an API that allows us to reduce the amount of context switching when we schedule an actor onto the thread pool. So this right here, what we're looking at is data from our in-memory ping pong benchmark. This is how we gauge the in-memory messaging performance of actors. Now there's several actors running in this benchmark. I don't remember the exact number, but this value on the left here that's scaling up, the throughput value, this determines how many messages an actor can process before it has to yield its execution time on the dispatcher to the next actor waiting in line behind it. The lower the throughput, the greater the amount of context switching. Now, there are diminishing returns in real life for having a high throughput value. So you can see here we set it all the way up to 900. That is an impractically high value and won't work very well on a real application. The true default value is 30. That's kind of our sort of happy medium, and that's just determined by empirical testing, not real. There's no mathematical formula for figuring this out. And this is basically what strikes the best balance between fair scheduling actors and reducing context switching. That's kind of the balance we're going for here. But one of the things that we did was we took advantage of this new API that we can't target in .NET Standard 2.0. And that's, these are the numbers of 1.449 on the left. These are the numbers of 1.50 on the right. You'll notice that we went from with a throughput of 1 with this group of, let's say, 30 actors running, we did about 9 million messages per second. That value is now 27 million messages per second with 0 end user code changes. All they're doing is just referencing the newer version of the library and running on .NET 6. So that's a 3x improvement right there. Well, if we take a look at when we're running a throughput of 900, you'll notice that we're doing about 70 million messages a second here. Whereas the highest possible throughput running under Akka.NET 1.449 was, I think it's about 54 million is about what we're running. Now we're doing about 70 million. And this is all as a result of just eliminating context switching. Essentially, there's a new low-level API that allows us to say, reschedule this actor onto the same thread if you can. If it's not possible, don't worry about it. But we would prefer to be back on the same thread that we were. This helps us avoid context switching, and the performance benefits for that are pretty demonstrable here. It's just kind of innate to what that change was. And this is something that doesn't require you as a Akka.net end user to do anything. You just need to upgrade your package. So that's one big change in Akka.net 1.5. This is the only real major breaking API change you should have to deal with. It's possible you might run into some others in the Akka.net test kit. That's kind of the other area that received a whole bunch of updates. I saw a pull request going into the Ockling project this morning, which is like the unofficial F# API for Akka.net, where apparently we broke a couple methods in there. Sorry about that. Those were mistakes. Those methods probably should not have been broken. But this breaking change absolutely was intentional. We broke the logging adapter. This code has basically not been changed in about a decade, give or take. And the way the logging adapter was designed from beginning with like Akka.net 0.4 or something like that was it was a bunch of methods that basically required you to pass in a log level or basically required you to pass in an exception, a format string, and then we had a params object array on there. The problem with that API signature, which was quite popular, 4 years ago, but the problem with it today is that is a very greedy API signature. It's very difficult to overload that with additional arguments. So as a result, we were kind of stuck with basically constantly having to allocate object arrays, which resulted in visible slowdowns inside end user actor code. We had customers that were doing IoT systems trying to push millions of messages a second, and the logger constantly showed up as a major source of like front-end bottleneck for them, which is incredible considering that the front end of the logger doesn't even do any string allocation or anything like that. It was just allocating object arrays over and over again, which is what was causing the problem. So what I did for Akka.net 1.5 is we made a binary breaking change. We got rid of all those params methods, and actually they still exist, but they've been renamed. And instead, we basically reduced the logging adapter to only have two really simple methods that need to be implemented now. And then we have a bunch of extension methods that call it. And those extension methods include a bunch of generic overloads that go up to, I think, 6 parameters. And we have them for each logging level. And they are completely source compatible with all of your existing Akka.net changes. So all you have to do is recompile your application. And if you do that, you'll go ahead and notice that the new logging API is at least 40% faster and allocates 50% less memory in most cases. This is because we use some read-only generic structs now to go ahead and capture all the arguments that need to be formatted into a string. And that will not show up as a source of allocations inside your actors when they're processing messages anymore. It's all zero allocation now. There's still, of course, allocations on the back end when we finally have to format the logging string. Can't really get away from that. But that's all deferred execution now. That shouldn't affect the hot path of your code. So this is one breaking change. And this kind of is a source compatible change, so it requires recompilation. The one thing you might have to do, we noticed this certainly in some of our plugins, although some of my applications I've installed Akka.net 1.5 into, I didn't need to do this at all since we already referenced the Akka.event namespace. But that's the one change you might run into, is that you might get a error saying that there's no method called info on the iLogging adapter interface anymore. That's correct. We moved it. So you might need to just go and reference this interface. You can use a global using as long as you're running C# 10 or 11, and that will help resolve that problem globally throughout your application. So that's what I recommend for fixing that. Probably the biggest area that we changed was actually the sharding system. Akka.net cluster sharding is much more scalable now than it was in Akka.net 1.4, and the throughput of it is also noticeably better. The reason why this is so is because we basically decoupled two different pieces of state the sharding system needed to manage. There's shard allocation data, which is basically keeping track of where specific shards are allocated throughout the cluster. And then there's remember entities data, keeping track of which entities on which shards need to be kept alive whenever that shard is allocated or rebalanced. Now these are managed separately. So basically the way I store my shard allocation data and the way I store my remember entities data don't need to be the exact same data structure. They're decoupled now. And what this does is this basically significantly improves remember entities recovery time. If you ever used remember entities with ddata as the backing store, you probably noticed that system was ridiculously slow. And that's because Lightning DB, which is what we kind of delegate that storage to under the covers, is not very performant in terms of its writes per second or reads per second. And that's one of the reasons why that was so slow. But then on top of that, if you used Akka.Persistence to basically store shard allocation data, you might have run into a scenario where some of the data your shard coordinator recovered after rebooting your cluster was corrupted. And as a result, the sharding coordinator would crash and need to be restarted. And you might have to go through and actually delete some data out of the journal for it. Well, sorry, it's a little hot in here, so I'm going to take my hoodie off in case any of you can see me on video. All right, there we go. The shard coordinator basically was a little brittle running under Akka.Persistence. The problem that we had using DData at scale was that there was a major messaging bottleneck with the way the shard coordinator was designed using DData that caused the system to be vulnerable to backing up. I was able to demo this using my large network test sample, for instance. That has also been fixed in this release. So Akka.Cluster sharding can be safely upgraded from Akka.NET 1.4 to 1.5. But if you're migrating your state store mode from persistence to DData, which is something that we strongly encourage that you do, this will require a full restart of your cluster. There's no way you can do this without downtime, unfortunately. Now, we have two different state store modes. If you use persistence as your state store mode, and that's still the default on Akka.NET 1.5, we didn't want to rug pull people and change that without their consent on this release. But basically, this state store mode still defaults to persistence. And if persistence is enabled, we're still going to use the Akka.NET 1.4 storage system. And that's fine. That'll continue to work. We encourage you to upgrade. And at some point, this default is going to get changed. It won't be today, won't be tomorrow, but it might be a year from now. So you should go ahead and make plans to do this migration at some point if you want to continue to upgrade. The new recommended settings, if you're using distributed data, if you're using Remember Entities, is to do DData and event sourced. If you're not using Remember Entities, you should still migrate to DData. That system is much more performant. It's not vulnerable to any of those data corruption issues that Akka.Persistence used to have. And it's going to basically reduce the amount of infrastructure you need to actually run cluster sharding. All you need now is just distributed data. You don't need a database anymore in order to run cluster sharding. So this is what we kind of recommend that you do. I'm going to skip through some of this. So our video that we have on our YouTube channel about Akka.NET 1.5, what's new, and our upgrade guide, that'll actually walk you through me doing like a live upgrade of a cluster sharded system. I definitely recommend that you watch that and ask questions in the Discord or send us an email before you try to do an upgrade. If you're concerned about it at all, would be glad to help you with that. Now, some other major changes in the core of Akka.NET 1.5 that shipped. Back pressure support for Akka.Persistence query was a big one. I wrote a whole blog post about this about maybe a few days before we shipped Akka.NET 1.5. Basically, we had a lot of users that were absolutely melting down their like production grade Postgres databases using thousands of persistent queries. And that's because they were generating thousands of requests per second as a result. Well, we now actually implement some back pressure support internally inside Akka.Persistence query that basically prevents. This is for SQL plugins currently. We haven't introduced this functionality for MongoDB or Redis or any other plugin yet. But for all the SQL-based plugins, we support this. And what this does is it basically rate limits the number of in-flight query segments at any given time. That way, your connection pool operates on a fixed count. So you can't have more than n number of open connections at any given time. And this will greatly improve the reliability of Akka.Persistence query. It does introduce a little bit of latency, but it's basically not measurable at low volumes. And at really high volumes, your database would be so bottlenecked anyway that the latency would be the least of your problems. So this is a pretty useful structural change we've introduced. The Akka.Test kit is now fully asynchronous under the covers. We use async await for everything. All these synchronous methods that we used to have in the test kit are still there. They just now are implemented using asynchronous ones under the covers. Whereas some of the async methods that we had in Akka.NET 1.4 were implemented the other way around. They were async over sync. Now we have sync over async, which is a big improvement. I've been rewriting some of like the Phobos test suite and some of our other components to use the async test kit, and it really does help improve the overall testing experience quite a lot. And I would also say I think it helps reduce how racy some of these tests can be because we're no longer doing things like sleeping threads or any of that sort of stuff. So it's definitely a lot nicer to work with now. We have made some pretty significant Akka Streams improvements, most of which will be invisible. Some of them won't be. There are a couple of breaking API changes here where we improved method signatures. For instance, there were a couple of types that did not return the right materialized value, so we fixed that. But the biggest thing that we've changed in Akka Streams is that now you can pass in the actor system as the materializer if you want. And we have the notion of a default global materializer now. So if your settings aren't different from what the default uses, we'll just reuse the same materializer over and over again. As a result of that, the amount of memory Akka Streams uses is like a tiny fraction of what it was before, since we're using the same cached materializer over and over again, essentially. So that's a really big improvement. You'll notice that if you're running an Akka Streams heavy application, you'll definitely notice a major decrease in memory stemming from that. We've made a lot of improvements to Akka.Persistence.Sql's built-in memory consumption. In fact, in Akka.NET 1.5.1, there's even more that are shipping. So more improvements to Akka.Persistence memory. And that's, I think, the gist of all the major changes. There might be some other little ones we did a while ago, like the watch async method, which gives you the ability to subscribe to the lifecycle actors from outside the actor system. That one's pretty cool. That's a new API that we added. We integrated, I think we took the system.threading.channels Akka Stream stages and integrated them into the core of Akka.NET 1.5. So you don't need a separate Alpaca package for that anymore. I just ran into that myself yesterday when I was doing some work on a project that used that. So there's a lot of other little changes and things we've introduced into 1.5 to help kind of improve the quality of life. And we'll do another video on some of the new modules that we added as well. But these are all kind of the important changes that we made to the core of Akka.NET. Now I'm going to talk about what else we have planned for the Akka.NET 1.5 lifecycle. But before I do that, I just wanted to pause and ask Gregorius. Gregorius, do you have anything else you want to jump in and add here before I move on? And you're currently muted, by the way.
Yeah, sorry about that. No, I think you covered everything.
All right, good. All right, well, let's talk about what's next for Akka.NET 1.5. So just to kind of reiterate, the goals for the Akka.NET 1.5 release, I've referred to this in our public writing and also in our original announcement video we did on this a year ago, that this is a paper cut release. We're basically trying to eliminate points of friction and problems for existing Akka.NET users. That's really kind of what we've been trying to address. There's other priorities that we kind of pushed out into Akka.NET 1.6, such as a bunch of performance fixes in the name of being able to prioritize and usability and developer experience first. So there's a couple of areas that are still under active development that represent significant features we're working on for Akka.NET 1.5. And the first is Gregorius' big project right now, Akka.Persistence.Sql. This is going to be a new unified Akka.Persistence.Sql implementation for all SQL plugins. So we right now today we have this Akka.Persistence.Sql.common library. This is designed to kind of not just replace that, but also replace things like Akka.Persistence.Sql server, for instance. And this project right now, in terms of the Akka.NET repository, is still called Akka.Persistence.LinkedDB, rebranded as Akka.Persistence.Sql. It's backwards compatible, the data from all existing plugins. Gregorius has painstakingly written a very extensive testing system to help ensure this. So that's been one of his pretty significant projects over the past several months. So we've been able to guarantee this backwards compatibility. In fact, all of that's passing right now, right, Gregorius?
Mm-hmm.
Yep. We've created, and here's the other really significant change. We mentioned as one of the things we wanted to support better in Akka.NET 1.5 is we wanted to have better support for CQRS, command query responsibility segregation, specifically the ability to make it easy for users to take Akka.Persistence data and project it into other forms their applications might want to use. So a lot of the normal queries in Akka.Persistence.Query run just fine on all the SQL plugins today, namely the all events query, the persistence IDs query, and in particular, the events by persistence ID query all work really well. But there's one query that is notoriously bad on that system, and that is the query by tag query. Tags are a feature of Akka.Persistence that allow you to put a secondary index on top of the data you're persisting. So, for instance, if you have a domain that consists of, oh, I don't know, let's say a whole bunch of user accounts, financial accounts inside a system, and you want to go ahead and record all of the debits and credits that user makes. Well, let's say you have a classification for a classification system for some of those transactions. Let's say you have a classification might be suspicious or might be really large or whatever, and you want to flag those and have a dedicated query that looks for those flagged transactions across all accounts. Well, that's something that the tag would be really useful for. You can go ahead and apply that tag. You basically wrap your payload when you call persist, and you pass in an array of strings, and those tags can be searched and indexed by Akka.Persistence. The problem with the way the original SQL plugins were developed is that those tags are literally pieces of comma delimited text that are added to a field that can't be indexed. So as a result, every time we want to search for tags, not only do we have to do a full table scan, but on top of that, we also have to basically parse this comma delimited or semicolon delimited column and filter out all the tags from there. It's an extremely resource intensive operation for really large journals. It was just a bad design the way it was originally created. So one of the things that Akka.Persistence.Sql aims to fix is that we actually are going to create a dedicated tag table that basically is essentially it's an index table is what it is. It includes the offset and it includes the persistent ID, the sequence number, and then the tag that was used. And we can go ahead and really quickly query the tag and the offset to paginate backwards and forwards on this query. So this should make CQRS quite a bit faster on SQL plugins for people who want to use those secondary indices. On top of that, the read and write performance of LinkedDB is substantially better than what you're going to get with the Akka.Persistence.Sql.com and based plugins. They're able to do things like batch reads and writes much more efficiently. And also there's the low-level syntax that Andrew, one of the other contributors who originally authored this plugin, implemented are all highly performance optimized in a way that the other plugins are not. So you'll see a pretty noticeable increase in improvement when this happens. All the other SQL plugins will be gradually rendered obsolete over the course of Akka.NET 1.5. So though my guess is in terms of how we're going to roll this out is there's going to be an upgrade guide similar to what we did for Akka.Cluster sharding. And that is going to basically roll out simultaneously along with a lifecycle plan for what we plan on doing with these other SQL plugins. Now, if you're using a system like Akka.Persistence Azure or Akka.Persistence.Redis or MongoDB, I think most of those systems actually already have pretty good indexing for tags. MongoDB might not. And in fact, I think Akka.Persistence Redis doesn't support tags at all because it doesn't work with Redis clustering, I don't think. So we're going to basically make sure that the CQRS experience should be pretty solid on any platform that's officially supported for persistence by Akka.NET. And SQL was kind of the biggest area where we had some major technical debt to pay off. And this is how we've decided it makes the most sense to do this. Rather than trying to handle migrations for 4 or 5 different Akka.Persistence SQL plugins, just have one and have everyone upgrade and standardize on that. That's what we're going to do. Next project, and I'm hoping to have I've actually made promises to customers along this line already, so I better damn well do it. But we're planning on having a prototype of Akka.ReliableDelivery available on NuGet by mid-April. This is designed to replace the at least one reactor is the whole goal of this release. So we cut this for the original Akka.NET 1.5 release date because we didn't want to block the Akka.Cluster sharding changes for any longer than we had to, since there were users actually being affected by the problems that cluster sharding fix solved. So we wanted to get that just out the door now. And since this is a new module and no one's using it, it's safe for us to do it that way. So the Akka.ReliableDelivery package is going to replace the at least once delivery reactor, and we're going to introduce 2 models of reliable delivery. The first is a push-based model, similar to what the at least once delivery reactor did, but it's going to work a little bit differently. Namely, it's going to support essentially every single consumer of events from this push-based system is going to subscribe to a stream of events that are going to be pushed into it via whoever the publisher is in this case. And those events will be maintained in a queue for that recipient in order. And that's going to solve one major problem the At-Least-Once-Delivery actor had, which is that it could deliver events out of order if they weren't received properly the first time. That's no longer going to be a problem. And then on top of that, we're also going to add a pull-based system where a subscriber is going to go ahead and basically pass in an offset, and it's just similar to Kafka, and it's going to scan for events up and down the offset as it processes them. Now, these models are going to ship by default. They're all going to be in memory, so there's not going to be any sort of persistence capability built into them by default. But optionally, they can be made persistent. You're going to have the ability to specify when you create, I think we're going to call these delivery controllers. Whenever you create a delivery controller, you have the ability to pass in a little flag that says they're persistent. And under the covers, they'll use Akka.Persistence to back up their state. But that'll all be done automatically now. It's not like the At-Least-Once-Delivery actor where you have to save that snapshot every single time something changes. The whole design of the At-Least-Once-Delivery actor just kind of sucks, in my opinion. So we're going to be gradually trying to phase that out and steering users towards this new Akka.ReliableDelivery package. We do not have any code for this written yet. That's on my to-do list. And I actually need it for one of our own projects, and we got several customers who want it. So this will happen in relatively short order here. We'll probably make it available as a beta. We'll wait a little while to get feedback. And by the way, if you don't like how this stuff works in the future and you're watching this call right now, blame yourself for not participating in the beta and giving us feedback earlier. That's how we make decisions on what stays and what goes. So get on it. Now, the next thing that we're going to cover real quickly for 1.5 is new .NET 6 APIs we're working on introducing. The whole purpose of .NET 6 dual targeting is to take advantage of newer modes of doing things in order to eliminate performance issues or in some cases reliability issues. A good example, we're looking to replace the built-in scheduler that we have in Akka.NET 1.5 right now with a new construct added in .NET 6 called a periodic timer. This should help reduce the CPU utilization of Akka.NET quite a bit. That's one thing we're looking at doing. Akka.io, we're looking to replace socket async event args with some lower level calls that use the socket.write async or whatever built into it. This might go ahead and help us improve throughput, not to mention error handling inside those systems. And then finally, there's a lot of stuff we can do with strings and spans, lots of new APIs we can take advantage of to reduce memory copying. This is a great area for contributing code back to Akka.NET 1.5 if you want to. There's probably a lot of different pieces of Akka.NET 1.5 that can be improved by taking advantage of newer APIs. All you have to do is kind of follow the same pattern we've done, where we use pre-compilation directives to say if this is .NET 6 or newer, basically then here's the new API call. If it's older than that, here's the current code that we're currently using today. So this would be a good area for contribution if you're interested in giving back to Akka.NET and getting some improved performance baked into Akka.NET 1.5. Gregorius, did I miss anything? Does that all sound pretty on board so far?
Yeah,
all right.
It is.
All right, cool. Akka.NET 1.6, the next big release of Akka.NET that we have planned. What's going to be happening in this release? Well, this is a performance-focused release. So if Akka.NET 1.5 was focused on development experience, Akka.NET 1.6 is focused on performance. So we have a couple of major goals already that are sort of set in stone so far. The first one is supporting ahead-of-time compilation, AOT. This is important for platforms like Unity 3D and Xamarin and Maui probably. And the biggest issue we have here is that some of the constructs that have been inside Akka.NET for many years, namely the receive actor and anything built on top of it, they all use the expression compiler under the covers in order to, originally, we did it in order to be fast. We did it in order to cache and reuse delegates. So that way we weren't constantly having to create closures and do them on the fly. That's what that was originally all about. That technique has served us well for many years. But due to JIT improvements and the fact that .NET is a much more global platform than it used to be, those techniques are showing their age and they need to be replaced. The most obvious candidate for replacing them is to use source generation to go ahead and statically compile those delegates at compile time and basically to go ahead and take the receive actor syntax. It all still looks the same way it does, but under the covers, we're actually going and are building a compile time structure to manage all of it. That's one thing I've just in theory put out there so far. Maybe there's an even simpler way of doing it that doesn't require that. We'll see. But that's one of the things that we're looking at doing. And this is primarily to make sure that Unity developers can use Akka.NET actors on the clients is what that's about. Improving Akka.Remote performance is probably the biggest structural goal. The biggest points of performance issues that we kind of have today in the entire Akka.Remote ecosystem really comes from Akka.Remote's TCP transport implementation. And it's not literally just the transport. Like I can swap out our .NET TCP transport with one that I built on top of gRPC. In fact, I actually do have that available as like a private repo at the moment. And guess what? The performance is identical between those two transports. And the reason for that is it has zero to do with how we move bytes from point A to point B. That is not the bottleneck of Akka.Remote. The bottleneck of Akka.Remote is that it is a stream-oriented design, meaning that messages and packets are written in the order in which they're received, first in, first out. So latency on the write and latency on the read on either side of the connection are going to determine exactly the pace at which the system can move. The biggest performance improvements we saw over the Akka.NET 1.4 lifespan typically came from improving the read side of the system. However, the fact that reads and writes are basically single-threaded is really the problem. That's kind of the issue that the system has. And we did that originally because that's how TCP works. And it's also what helps us preserve message order most simply, is using a stream-oriented protocol like that. However, it is a problem if we want to improve the throughput. And let's say, Akka.NET running on .NET 7 with server-side garbage collection and Akka.NET 1.5 and dynamic profile guided optimization support. You could probably do, I think on my system, I did about 450,000 messages a second, and that's pretty fast. But if we want to get to, let's say, 2 or 3 million messages a second, or even 1 million messages a second, we're not going to be able to do that through just clever improvements to the system code. That's basically implementing our current transport. We have to fundamentally re-architect it. And we have to re-architect it and move toward a multiplex design is what we need to do. What this means is that even though, let's say, there might be literally a single shared TCP connection, or maybe there's a single shared UDP connection with some reliable, UDP is not connection oriented, but you get what I mean. There's a single shared, let's say, UDP connection between these two endpoints that uses some reliable delivery. What multiplexing means is that you can take one stream of data and actually run it in parallel, like without multiple threads and without multiple connections, as several parallel streams that are all being written that can interleave simultaneously. This was actually a technique, believe it or not, originally invented by Thomas Edison for being able to support higher messaging throughput on telegraph systems in the late 19th century. So multiplexing is basically kind of the new thing that every high-performance networking system is working on. HTTP 3 is going to be built on top of the QUIC protocol, for instance, which is all about multiplexed UDP connectivity. Artery, which is the original JVM implementation for their high throughput transport, uses Aeron, another multiplexed reliable UDP system to do that. We're probably going to be building our system using a very similar design. It might be on top of Aeron. Aeron now no longer requires the JVM, which is one of the big blockers for it. There's precisely zero chance I was going to tell .NET developers, oh yeah, you just need to have Java installed on your machines to use Akka.Remote. Hell no, that would never happen. Users would never accept it. But now there's a version of Aeron that uses basically like some native p-invoked DLLs that should work. Or potentially, if we want to go ahead and bump Akka.NET 1.6 to target .NET 8 going forward, there will be an implementation of MS Quick that should be generally available to users there. That's what ASP.NET and SignalR and the .NET implementation gRPC, they're all going to be written on top of MS Quick starting in .NET 8. That's how they're going to support HTTP 3, for instance. So we might pick one of those two sort of options for transport. But really, it's not the moving the bytes from point A to point B that's an issue here. It's that the underlying way our remoting actors are designed needs to be a bit smarter. It needs to be able to handle multiple streams of information all being laid on top of the same physical connection. And that's straightforward to do from a conceptual standpoint. From an implementation standpoint, doing that and dealing with all the fault tolerance issues at hand there is a little bit more complicated. So this will actually be a fairly substantial project. Um, One of the things we had to do to support this project is we're going to rewrite the Akka Streams materializer. This is the infamous phase fused actor materializer, if you've seen the issues for this. The idea behind this is that the new Akka.Remote transport is going to be built on top of Akka Streams in order to properly support back pressure. And there's certain types of work it can do while it's waiting for the transport to get ready, like serialization, for instance. We need to go ahead and improve the materializer a bit in order to make sure that it's able to compile those streams quickly. That's the reason why we want to do this. Compiling the streams quickly and making sure that the streams are built as efficiently as possible. That's the whole reason for even touching the materializer here. Finally, one of the projects I've been very interested in doing is redoing the serialization system. Changing the default serializer in Akka.net is one thing, but really, I think trying to simplify the way Akka.net developers have to implement serialization best practices is the goal here. Today, if you want to go and write a schema-based serializer, which is what we recommend that you do, that typically means having to define your own protobuf messages, having to go and create your own serializer class, mapping between those protobuf types and their manifests, and then mapping those back into C# classes that you wrote. There's quite a few steps involved. And the benefit to doing that is you get something that's really fast and very version tolerant. So it's pretty robust across upgrades and it's consistently pretty good performance. The downside of doing that is that it's a lot of manual work, and most software developers are lazy corner cutters, for lack of a better word, who will not do that. So one of the things that we're looking at doing, and you'll see a theme start to emerge here, is you're looking to use source generation to basically either reflect upon metadata attributes users add to their classes. This will be similar to something like protobuf.net, for instance, or possibly going and just taking a look at anytime someone does an actorref.tell, analyzing whether or not this message might be going over the network based on certain patterns and attributes. And if it is, then we go ahead and we generate a serializer for it that plugs into Akka.net's existing serialization system. And the other important facet of doing this is that if we have to regenerate that serializer, we can detect to see if there's been breaking changes made to the wire format, and we fail compilation if that happens. That way, users can't foot gun themselves by doing a giant refactoring or something like that if we don't want them to. So that's kind of part of the goal for doing some of this for Akka.net 1.6. Our target due date for this, I have no idea when we're going to finish our work, but we're planning on starting it at the beginning of Q4. So we're about to end Q1 here. We've got a bunch of work on Akka.net 1.5 that we're planning on doing over the next couple of quarters, but we have some other big projects planned beyond just what we've shown you on screen here. I'm working on a brand new software as a service application that I've been talking about for months now that'll help improve the observability experience of Akka.net quite a bit. We're planning on launching that before we start work on this. We're going to be modernizing all of our documentation tutorials to take advantage of Akka hosting and some of the other new best practices. That's also on this to-do list. And then lastly, I think it's probably overdue for us on the Petabridge side of things. In fact, I'll go ahead and pull myself and Gregorius up here. We're probably overdue for this on the Petabridge side of things, but I really would like to redo Akka.net Bootcamp and some of our other online course materials to be more modern and also to cover more things. In fact, one of the things I'd probably really like to cover in some of our expanded materials, talking a bit more about some of the distributed systems best practices, such as our Akka.net clustering and remoting and cluster sharding, persistence, data, all that good stuff. So I really like to expand our collection of courses. That is very labor intensive and takes quite a bit to do. I think for producing our online webinars that we've been doing for since 2015, I think each one of those webinars took me at least, I think, 120 hours to develop. And that was, to bear in mind, I'm a bit faster at doing that now. We have a much larger pool of existing material to draw from, but still structuring things for users and in a way that kind of makes the information approachable to people with a variety of backgrounds and experience. That takes quite a bit of calibration to kind of get that right. But these are some of the things that we want to work on over the course of this year. Our goal, of course, is to go ahead and try to continue to build a big tent around Akka.net. We want as many people getting as much value out of it as possible. And so we are, pretty responsive to demands for additional training materials, for more examples. That's probably the number one thing that comes up in our Akka.net survey, which we'll be doing in the month of April, by the way. So that comes up quite a bit. And then on top of that, improving the performance of Akka.remote. That's something that we know a lot of users who are using Akka.net in spaces like finance and sports betting really want, and also video games. So we're going to make sure that we get that addressed as well. We're always trying to do better and better by our users here. And we really want to thank you for all of your support that you've shown us over the course of Akka.net 1.5. We know it was a long time coming. I think we've delivered a really good product that I'm proud to stand behind. I'm really proud of the work that our other contributors added as well. I think we had something like 25 people contribute to the core part of Akka.net. That doesn't even count all the people who tested the beta, reported bugs, or the people who tried out Akka hosting or Akka Health Check when it was new. So the real number is probably far larger than that. But either way, definitely a big thank you from us to you, the users, for helping make this a big success. And I guess on that note, if you have any questions about upgrading, you can always reach us in our Discord. Me and myself, Gregorius, and the other contributors tend to hang out there. And there's also lots of users who can answer your question as well. GitHub Discussions is another good place you can try to track us. And then lastly, if you want some commercial help upgrading to Akka.net 1.5 or doing a design review or anything like that, you can always contact us here at Petabridge. We regularly sell that as a service. I'll wait to see if there's any I'll wait a couple minutes to see if there's any questions in chat. But otherwise, Gregorius, anything you want to add to this?
No, not really. You covered it really well. So,
oh, well, thank you. Appreciate that. Well, I think on that note, we'll go ahead and end our March community stand-up a little early. Now, one thing I will add is that we are looking for some additional show and tell speakers, and I will be emailing some folks on our mailing list who I think might be good candidates for doing that. So by all means, if you can share a story about how you're using Akka.net in your place of work, that's always really helpful to us. It's one of the best ways you can go ahead and give back to the project. And it really kind of goes to help spark the imaginations of other users too. So thank you very much for your time this month, everybody. I really appreciate it. And we'll go ahead and catch you next month. Take care, everyone.